So for worksheet 1, the first question is, what is the logical AND operator? The logical AND operator is the double ampersand, and the logical operators are usually the double characters. And number 2 was, what is the bitwise OR operator? Bitwise OR operator is the single pipe character. This is bitwise AND, or logical AND, bitwise OR. And what is the result of a bitwise AND operation of 3C with F0? Number 3, 3C, F0, added together. So 3C is 0011, 1100, F0, 1111, 0000. And when they're added together, when there's two ones, you get a 1 on the output. All other cases are going to be 0. And number 4, what is the result of a bitwise OR operation with C3 and 0F? So this is kind of like the same question, but it's given in hexadecimal. So it's 3C with 0F ORed together, and 3C, C3? C3, you're right. C3, 0F. And when you do a bitwise OR, if you have a 1 in either the top or the bottom, you get a 1 on the output. All other cases will be 0. Or you could conversely say, if you have two zeros, you get a 0 on the output. So, and I guess for completeness, right, if we converted this back to hex, this would be 30, and this would be CF. Now, one thing you can see here is when you do an AND operation where you have zeros, you're masking whatever's up here gets blocked out, and you end up with zeros on output. And wherever you have ones, it's copied through. So you get the 3 from the top number and the 0 from the bottom number. And it would work in reverse too if the F0 was on the top and the 3C was on the bottom. So, and they usually call this a mask. You're masking bits. And on the OR, something happens similar. We have a 0, it allows the bits to pass through. And where you have ones here, they all get set. So this sets, the OR will let you set bits. See, number 5 is, what truth value does the following C language condition evaluate to? 5, F0, 1. So the first part, so the parentheses create your precedence. So you have to do everything inside the parentheses first. So you need to do this bitwise AND operation first. Hopefully you could see, because there's a 0 in the high nibble here and a 0 in the low nibble here, that this whole thing here is going to evaluate to 0. From the AND, right, wherever there's a 0, when you have an AND operation, you get zeros in the output. And since this whole high nibble is 0 and this whole low nibble is 0, this whole thing is going to evaluate to 0. And then it's going to be a logical OR with 0x, 0, 1. The truth value here, this is true because it's not 0, and this is false. A true ORed with a false is going to be a true. And in C, this will probably evaluate to, I would accept true on this. True would evaluate to a 1. Number 6 and 7 have to do with this little simple program. We have an 8-bit variable called I, an 8-bit variable called X, and a while loop, well, I ANDed with 0x, 03, I equals I plus 1, and X equals I. So the first question is, what will X be when the following loop exits? So the while loop, it'll go inside this loop and loop as long as this condition is true. So as long as this evaluates to true. Oh, I missed one thing. There's I equals 1 here. I don't know if I mentioned this before. When you declare a variable in C, you can't make any assumptions about what value it is. It may be 0, it may be not 0, it could be any value. In Boost, most of the time they end up being 0. But you're not supposed to rely on it. The C programming language says don't rely on what this value is. You must specify something. So I equals 1. 1 ANDed with 3. So the first thing we have is we have 0x, 0, 1, because I is 1. So this is I. we're going to AND it with 0x03 in binary, and it's ANDed. And so where you have two ones, you get a 1 on the output, the rest are zeros. So that's not 0, so it's true. So this goes in. So we've gone in one time, and we get this I equals I plus 1, so I is now equal to 2. So I is equal to 1, 1 plus 1 is 2, 2 is reassigned to the value of I. So I is now 2, and we've gone into the loop, so we're going to count how many times. We've gone into the loop one time. So this code is run one time. We go back up here, and this gets reevaluated, but I is now equal to 2, and so this is now equal to 1, 0, and when we do the AND operation, this becomes 1, 0. That's true. It's true because this is not 0, so we go into the loop again. I now becomes 3. We come out of the loop, and we go up here, and we check again. We've gotten into the loop 2 times now, and so we need to reevaluate this guy. So I is now equal to 3, so this is 3, and this is 3, and the result of the AND operation is 3. 3 is a positive value, so it is not 0, and any non-zero value is true, so we go into the loop. I becomes 4, we've gone into the loop 3 times now. We exit, come back up here, and now I is 4. And so in binary, this would be 1, 0, 0, and when you AND these together, you get 0, 0. That is false, so we exit the while loop, and we go down here, and x gets assigned to the value of I. So x now equals I, which equals 4, and we have both the answers. So for number 6, what will x be when the following loop exits? So x is equal to 4, so this is the answer for number 6. Number 7, how many times will the loop have been run? The loop will have been run 3 times. And for number 8, says, what is the voltage potential at the button net if the button is not pushed? So we have a schematic that looks something like this. There's a button that it's got 2 connections to it. I think there's some nodes on the schematic like that. There's a 0.1 microfarad cap. 100K. The net is named button. This is what it's asking about. The net named button. What is the voltage potential at the button net if the button is not pushed? So this is the net that has been named. It is named the button. So if the button is not pushed, this is open. When you first turn on the circuit, right, these make it an RC time constant, so you're going to have some voltage charging up. So unless you first turn the circuit on, you know, at the very start when you turn the circuit on, you're going to get this RC time constant where the cap charges up. But once the cap's charged up, you're going to see 3.3 volts here if the button's not pushed. So the question was, kind of ignore the time constant at the beginning. That's only going to be, you know, a few milliseconds or something. But the steady state of this, when the button is not pushed, will be 3.3 volts. As soon as you push the button, though, it's going to be a short to ground. It'll short the cap to ground. There's 0 resistance. The time constant is very fast, and so you go straight to 0. When you let go of the button, you're going to get that charge again, and that's the debounce we had talked about before on the button.